Alright, welcome to your very first video lesson in chemistry. We're going to kind of quickly go through and allow you to begin to differentiate between accuracy and precision, and we're also going to be showing how to reflect precision when recording measurements. Accuracy is going to be how close our experimental results are to the actual or true value for the quantity that we're measuring. We're going to evaluate accuracy in the lab by performing a percent error calculation. We're going to be looking at the reference table. This will be an equation we use throughout the year in order to see how accurate our measurements are. But there's another term called precision. This is how well a measurement can be reproduced if the same object or substance is measured multiple times. So even though we could have something that's inaccurate, our precision could be pretty high in terms of us hitting the same point multiple times. So this example is showing us where we have precision. The darts are very close together. That person aimed to the same spot fairly well. However, they didn't hit the bullseye or nowhere near it, so it's inaccurate. Here we can see that on average, they're pretty close to the bullseye. However, they're fairly spread apart. So those darts, while accurate, would be considered imprecise. They're hitting different parts of the dartboard. And then here we have where the darts are very close together and they're on the bullseye. So finally we see an example where it's accurate and precise. So we talked about how accuracy is going to be reflected in our percent error calculations, but how is precision reflected in chemistry? Well, the precision of a measurement is completely limited by the instrument we use. There's various degrees of precision in instruments that measure very similar types of substances. So a method for handling uncertainty in all the measurements is the use of significant figures. You're going to be hearing me say that term over and over again, so a lot of times we simplify that to sig figs. This arises due to the fact that we have different equipment with different degrees of precision. So when making measurements in the lab, we keep all the digits that are known so that the instrument is actually giving us based on the instrument's increments, plus only one estimated digit. So when measuring, the last digit is an estimate, and it represents the precision of our measurement. So here, it's just, you don't need to write all this down, it's just what you would like to do with it. We have a beaker, a graduated cylinder, and a burette. With our beaker, our increments go up by tens along the side here. Thus, we're going to estimate the value of this measurement to the ones place. Here, our increments go up by ones. Thus, you can estimate the value to the tenths place. So again, increments are by ones, so we can go and estimate one additional place value, which is to the tenths. In our burette, increments go up by tenths. Thus, we can estimate to the hundredths place. So you can see as we go from beaker to graduated cylinder, so you can see the values here. So as we go from the beaker, which measures it to 25 milliliters, the graduated cylinder, which would give us 25.2, and the burette, which is the most precise, 25.28, we're increasing the precision, which is based on our instrument and the increments that it provides us. That's why usually for beakers, we only use them for mixing, carrying them around, or reacting, while graduated cylinders and burettes are used for measuring our liquids. And usually burettes are really only used when we need a very high degree of accuracy. Alright, so in your first example, you're going to see two different rulers here. Here we have it going to the tenths place, so that means then we would read or estimate one additional place value, which would be to the hundredths place. So here our measurement would be 0.48 centimeters. The 8 in our hundredths place is our estimated digit. We had to estimate between the 0.4 and the 0.5 where we felt that line went to. And then in our second example, we can see that this device is marked to the tens place, so we're going to then go ahead and read that to the ones place. So our measurement then would be 67. It would be incorrect to write 67.0. So what I mean by that, let me see if I can get this to show up for you. Nope. Oh, pointer options. Sorry about that. If you were to write here 67.0, that would be incorrect because you're going beyond the precision of this instrument in particular. Alright, for our final kind of main example here, we're looking at a graduated cylinder. The smallest place value of the device is to the ones. Each of those increments is worth a 1. And then we estimate then to one additional place value, so we can estimate to the tenths, which means our final answer would be 43.1. So again, we can't go beyond that tenths place. We also have to make sure to include it. If you had decided to answer as 43, you felt like it was exactly on 43, you would still have to make sure then that you included that 0 to show significance to the tens place. So something we'll touch on tomorrow as well. All right, what I would suggest doing is pause the video, try out these 3 examples, then check your answers. All right, hopefully you've had a chance to try them out. We're just going to quickly kind of go through these, bring your questions tomorrow after we're done going through them. So this first one you should have somewhere around 46. The big thing is that this one has to be estimated to the ones place. Our example number 2 should be going out to the hundredths place. Okay, each of these line segments here or increments is to a tenth, so that means we have to estimate to that hundredths place. And then finally for number 3, you should get negative 11.0. Okay, you need to make sure, I felt like this was right on the line for negative 11, and because this is increments of ones, I had to make sure I showed that tenths place as being significant, so that's why the 0 is placed there. Alright, so you are all set. There should be a little question at the end of the video to just record a little summary so that I can verify that you have watched the notes and you are all set with your very first video lesson.